Alright, we've heard of MOSFETs as being resistors or current sources and stuff like that. Well, let's pause here to really understand what that means as to how a MOSFET behaves when it's a resistor or when a current source, or we could also call it when it's in triode or in saturation as to how it behaves. So, well, you must have seen in a lot of books that, whoops, that was a very bad line. Okay, here we go. Still is a bad line, still, let's manage. Okay, so we say that a MOSFET has so and so IV characteristics. Let's consider the dotted lines to be straight. Let's say this is the drain current, and say this is the drain to source voltage. Okay. All right. We say, let me grab a different color. Okay. We say that till this point here, it is triode, and all this part is saturation. So just remember this diagram, we'll come back to it till later. So before doing that, let's understand what basic graphs are, curves are. Let's say this is the coordinate axis, and when you want to name the axes as current or voltage, the first thing you have to understand is what is your controlling parameter. In a MOSFET, you're going to give some gate voltage to control the drain current, correct? That means the controlling factor is voltage, and the controlled factor is current. The controlling factor should always be on the x-axis, just like we do even for ECG. Have you seen? So what this happens, what is on the x-axis is time, and I think this is the magnitude of pulse or something. Well, it doesn't matter, but the controlling factor is time. That's what we control, but the pulses are what's read off the ECG. Likewise, here we control the voltage, and the controlled parameter is current. So in a coordinate axis like this, let's say this is a straight horizontal line, just say, and this is a straight vertical line. What does the horizontal line say? It says for any voltage, no matter what, any voltage, the current is constant. Let's say this is 1 amp, 2 and 3 amps. This is 0. No matter what voltage you give, my output is always going to be 3 amps. That means no matter what voltage you give, my output is always going to be constant current. And a device that gives you constant current for no matter what voltage is called a current source. Likewise, for the vertical line, for any current, your voltage is going to be constant. So you guessed it right, it's just a voltage source. Now what about a line that looks like this, passing through the origin and has this little slope here? Don't mind my all bent lines. So what does this inclined line show? For 1 volt, your current is 1 amp. For 2 volts, your current is 2 amps. That means the slope of the line, delta I to delta V, is constant and even reverse. So from our prehistoric definition of Ohm's law, what do we know? Under constant temperature and stuff like that, environmental conditions, the ratio of voltage to current in a given conductor is constant and is given by R, the resistance of the conductor. So this sloped line shows the IV characteristics of a resistor. That means anytime you see a sloped line on an IV curve, IV graph, you know it's got some resistance. If it doesn't have any, well, let's see here. If it doesn't have any inclination, it's going to be a current source or a voltage source. Alright, so we'll come back to these till later. So now that you got that an inclined line always means resistance, let's go ahead and look at this here. This inclined line here you're seeing is that of a MOSFET when it is in triode. That means when it is in triode, well, it's more inclined than this line, but then doesn't matter. When it is in triode, your MOSFET is going to behave like a resistor. Don't really worry about how much resistance. It's just a resistor. Okay? But look at the saturation thing. You might say that it does have an inclination, but it's not only a resistance. How do you know it's not only a resistance? If you extend this on that graph, your 0 point is going to be obtained somewhere here where the voltage is negative. So here your voltage is positive and you have some slope here, and here you have a voltage is negative but you have a zero current. So the slope's all well, you can it doesn't have a constant slope because it doesn't pass through the origin, correct? Alright, now what does that mean? That means the inclination when it is in saturation is at an elevation. Okay? It is lifted from the ground by a finite value, say 1 milliamp. Correct? And above that there is an inclination. That means, just consider this line to be a forklift. It lifts the basic value of current and it gives you a 1 milliamp, and over and above that, whatever voltage you give me, I'll be increasing some current. That means if there's a horizontal line, what do we know? It's a current source, correct? But there is also an inclined line. Let's say, well, let's see what this really means when a MOSFET is in saturation. We know that an inclined is going to be a resistance and a horizontal thing is going to be a current source. Let's see how this will work if they're both connected in series. One milliamp is the current given by the current source. If you see here for a MOSFET, this place is more than 1 milliamps, correct? That means there is an increase in current with increase in voltage. But in a series circuit, the total current here is just 1 milliamps, because in a series circuit the current remains constant. So what can we do to increase current here? You guessed it right again. We have parallel connections. Here I'm getting 1 milliamps from the current source, and say the resistance is any value, say 5 kilo ohms. There will be a current passing through this and here. So whatever you get will be 1 milliamps plus some current from here, which will be more than 1 milliamps. Correct? That means in saturation a MOSFET behaves like a current source in parallel with a resistance. Cool. See you later.